Hi, I'm Nathan Malin. I'm in your Management 41310 class, and I'm going to be talking about session three, which is data quality and data cleaning for stocks. The stock that I chose was Kohl's, and I had a very deep interest in it because of recently with the meme stock and how there was a couple days last week in the trading week where there's high volatility within the market. And Kohl's was one of the beneficiaries of this, as their stock really, really soared. And I really just wanted to see and I wanted to clean their data, as I really just thought there could have been some data quality issues, especially with some outliers and extended Z scores that shouldn't even been there. And this is the code that I use to help me clean this data. So this is a simple cleaning for Kohl's, which is their stock ticker is KSS. So I first imported Yahoo Finance and I imported PEMDA. Or no, sorry, not PEMDA, Panda. And my first step was to set up the stock. So my ticker is KSS. My name was Kohl's. And we printed out cleaning Kohl's as our intro. We downloaded our last 1 year of data by doing stock equals Yahoo Finance and the ticker symbol, which is ticker equals KSS. So it's go on KSS and Yahoo Finance. And for um for the data, it'd go with a period of 1 year. So it'd have 1 year's worth of data. And I use a few indicators or a few ways I try to clean this data and try to flag things with this data. It's obviously the first thing is to identify which is actually missing and what needs to be cleaned. So our missing count is the first thing I chose, is obviously I wanted to see if there's any missing data that shouldn't have been there, like an NA or something like that. So this code would basically look if there's an NA, it'd add them all up. And then also I did the same thing for bad prices. So when it found a closing price that was less than or equal to zero, it'd add all those up and count it. And then I wanted to print out all the missing close values and all the zero negative close values, which are just bad prices. So all the prices that were less than or equal to zero or missing count. And then I also wanted to fill missing close values, as I wanted to do a forward fill. So if it was NA, I'd have the next stock's piece of information, and then it'd go backward the day. So it'd fill all those data in. It may not do that much, but like the little things are what really, when you're dealing with $2 million asset under management or more or something like that, these big investment decisions, especially when you're dealing with like small inconsistencies, can really affect it. So when we're also setting up the adjusted close, it's just the regular close. We basically made an adjustment with not only filling the missing values, but as I'll talk about later, I also wanted to remove all the outliers as well. So that was another way we're going to clean our data and give this adjusted close, which is just the new close after we adjusted it and cleaned our data. So we also wanted to get our daily return. So this is the formula we use to actually get our daily return. And it's the percentage change every day. So as every day passed, it'd go the percentage change of day over day. And then this is an extreme move, is what I called it. It was basically just high volatility in a daily trading day. So for the daily returns, the percentage change would be more than 10% or less than 10%. So I use the absolute value. It creates something called an outlier count, which would be we'd add them all up. So we see how many outliers there were. Then I also wanted to calculate the z-score as well, as the z-score is a very statistical way to actually interpret data. Um, so first of all, I got my mean return with my daily return for the mean, and then I get my standard deviation, which is just daily return for the standard deviation, and then I'd get my z-score from that. So I'd use the daily return minus the mean return, so every day, and then I'd divide it over the standard deviation. And then basically I got an outlier from that piece of data, and then I also made sure that if the absolute value is more than two for this equation, and add it to our z-score, which are our z outliers, is what I called it. And when we get that, it'd print out more than that. And then it average the daily return before. So the daily return before I made that change with the data cleaned. So basically another way I cleaned it. So the average return was just based off of this. And then if this was false, which means that if there are any daily move, it'd add it to the data cleaned. And then my average return after was just the same percentage, like the same total average return over the year for all the daily returns when you actually clean that data. So daily cleaned and then the daily return. And then also I got printing final missing adjusted close values, total clean data points. So I also wanted to know how many pieces of data I was cleaning. So basically, if it would remove data, it'd probably have less data values. And then average daily return before the outlier and then average after. So here is my outputs. So I had missing close values of 0, which is good, 0 negative close values, which is good. So there's no bad or missing data. So that did not have to be clean. It actually didn't actually affect the daily return or percentage change. But what did actually affect it was the extreme daily moves, which is more than 10 of them. So basically, I chose a stock because of last week in high volatility. There's 10 trading days already where this stock really moved over 10%. And the Z-score said the same exact thing. So this clearly had to be cleaned. So before there were 240, and after cleaning it, there were 240 trading days that it actually were. And then basically a negative 0.05% difference really just tells how important this piece of data cleaning is. Is obviously that can really just change an investment decision based off of that. If you're dealing with high money, as obviously all hedge funds, institutions were doing things like that, making sure that a negative 0.05% can actually do a lot in affecting an investment decision if you really think about it. And also it's just healthy to have really good data in general. And when we're validating this code, I use a stock symbol KSS. I downloaded all the raw data like I did earlier. And then I did the data close is more than 0. So I basically fill those missing values and remove bad prices. And I just wanted a total completeness score. So total days minus missing over total days. That I just wanted to make sure that it was at 100% if there were no missing data. And also I wanted to check the price reasonableness, which is the minimum to maximum price and then the price ratio. Then I also wanted a reasonable return check, which is just a daily return percentage change. And then the average, if the daily return was more than 10%, it'd add those up and give me an extreme return. And here's the results. So I printed them all out that I wanted to. And it basically returned ticker symbol KSS with 250 trading days. So obviously that shows that we cleaned 10 because it's more than 10%. We originally had 250. So that equals 240, which is the amount that it actually had cleaned. So that actually validates everything. There's 0 missing close values, so 100%, so there's 100% completeness. And the price ratio was more than 2, which was not, it was like it's probably a Z-score proxy. It's not an exact Z-score, but a reasonable, like a reasonable price range is just like that when the price ratio is less than 2, and the price ratio, as I calculated, was the max price over the min price. So that basically was my litmus test for a reasonable price range. And here's the price range just to have it as just to be there. And I think that a lot of bad data can really affect investment decisions, as I've already talked about. And I think this really just showed how much cleaning can really affect a piece of data. And especially when I'm validating it, it also just really just like especially with that reasonable price check, it can really just support the fact that Z-scores are a major thing and also had the validation of 250 minus 10, which is 240, which is my post-cleaning completeness score, as I showed you earlier, right here. So I think that's also really important. Things I kind of probably done better. I probably shouldn't have chosen also having a Z-score and printing it out at the end for data validation. But I just chose against it as I thought the price ratio would have been just fine. And I really just tried to do a better job of just explaining the data validation. I think I could have probably formatted my code a little bit better. So I think some things were out of place, and I think I could have put it a little bit more chronologically or kind of made it easier to read. But I think I had all the code there. It just wasn't really well formatted. And I think just overall, I think I really just learned a lot about how data cleaning can really affect and change an investment decision, change an outcome. I didn't realize how big of a change it was. So, thank you.